Now let's take a look at the second approach that we call binary tree approach. And there when we generate subsequences, what we start with is, let's say we start with a path array and we say this is the path array that we are bound to. So when we start with this array, we say array has element 1, 2, 3, and this first position that we need to fill has two choices. So this time we are going with two options rather than going with n options. And that option is, when we are at 1, we say 1 can be included. So this is the inclusion path of 1, and 1 can be excluded. So if 1 is included in our path array, we fill 1 here, and we say the next elements have to be filled from the remaining array 2, 3. Right? So this is the left path. Second, if we say 1 is excluded, then what we do is path array is not yet filled as of now, and the remaining array is 2, 3 here. Right? So we still have to fill the 0th index, and here we have to fill the 1 index going next. So again, at this second point where I is 1, we have two choices, whether we exclude 2, include 2, and when we exclude 2, right? So when we include 2, the path will become 1, 2, and we are searching for what will come at third index. And when we go to the right side, we say 1, and second position needs to be filled with the remaining element 3. Right? So at every step when we are going down, the current index, whether we select it or we leave it. So let's take a look at this approach in subsequences. So in this approach, we do not have to write a loop to print subsequences because we always start with A. Index will be 0. Start index of path array we need to pass as 0, and we'll take a path array. When we come here now, let's make our choices. When we are at this position at this index, so we will say path array will fill pi with two choices. First we are making is, let's say we are including. So when we include, we will say a of idx represents inclusion of a of idx. And after we have included this, we print path and we go and print p to pi. This we will be writing a separate function so that current path that we have generated, we end up printing that also. Included index. We'll write that function in a short while. After this is included and we have went down, we have printed a path. Now we explore the second choice, and the second choice that we will have is, we will say here also we will make a recursive call. Here since we included, we need to make a recursive call after inclusion. We will say print subsequence helper and we will say a n. Now we have to select the element from idx plus 1. In path array, we have filled pi plus 1. Inclusion path always looks for what is the next element. In exclusion path, we make a recursive call. And in recursive call, we tell to that we start from the next element onward in path array, but print the element or put the element as pi. So we are going to overwrite the same index. So this is called the excluded. Now if we go and look at the base case, we'll say, boundary case, we'll say if idx is greater than equal to n, then we end up returning. This is a different version of generating all the subsequences, and here we are talking about taking just two recursive calls. This is 1, this is 2. In previous we took n recursive calls, or we can say the recursive calls leaving the current element. Let's complete this function next line. We print all of them at new line. This is our binary tree approach. Let's go and compile this code. So C++ brings in. We run this code. Subsequences are generated and printed with this approach.